you click this video to watch an intro to exponential function, but you are looking at a bunch of functions that are not related to exponential function y. So just allow me to take a minute to review what we have learned so far, and then I will bring you to the intro to exponential functions. So I have 6 functions right here, starting with the one on the left. So we have a linear function, that is the easiest. We have f of x equals to ax plus b. So for example, f of x equals to 2x plus b. The slope is equals to 2. The y-intercept is x equals to 0, y equals to 1. So linear function is a straight line. So linear function is a straight line. The reason that this function is a linear because the independent variable x is raised to the first power, right? And then moving on to the next one, quadratic function. So quadratic function means the independent variable x is raised to the second power, and then the graph is a parabola. The vertex is at 0, 0. So for x squared, we have a parabola. And then how about the third power? So a cubic function, x raised to the third power. So when x raised to the third power, that means y can be negative, right? So back to your quadratic function, every time you take a number, negative, positive, or 0, you square that number. The number is always 0 or above. 0 square is 0. 1 square is 1. Negative 1 square is 1, right? Negative 5 square is positive. Negative 1 million square is positive. So for parabola, the curve is always above the x-axis. But for third power, so if you take x equals to negative 2, negative 2 raised to the third power is negative. So that's why for a cubic function, we have a piece that is in quadrant 3. So when x is negative, y is negative. So that's why for the third power, the cubic function, the entire curve is not above the x-axis. All right, and then we have the square root function. The next line, square root function. So the square root function is an increasing function. The function starts at the origin 0, 0, and then when x is positive, y is positive, right? So let's say the square root of 9 is positive, is equals to 3. So x is positive, y is positive. The reason I said x must be greater than or equal to 0 is because the square root of negative is undefined, right? So the square root of negative 8 is undefined. The square root of negative 4 is undefined. The square root of 0 is defined, so that's why 0, 0. The origin is a solid circle, right? It's a solid dot right over here. And then the cube root, so the cube root, so you have a radical sign, and then you have a radical sign, and then you have a 3. So that is the cube root. Cube root means x raised to the 1/3 power. So in this function, the domain is all real numbers, because for cube root, so if x is equals to negative 8, the cube root of negative 8, that is equals to negative 2, because negative 2 times itself 3 times is equals to negative 8. So that's why when x is negative, y is negative. And since we can pick x to be negative, so the domain is all real numbers. So you can pick 0, x, positive x, or negative x. So that is the graph of cube root. And then the last one is the reciprocal function, is f of x equals to 1 divided by x. So 1 divided by x, another way to write that is using negative exponent, which is x raised to the negative 1 power. So since you have x in the denominator, you have to specify that x cannot be equal to 0. So therefore, when x is equals to 0, there is a vertical asymptote. All right, and then as x approaches to positive, so as x approaches to positive infinity, y approaches to what? Y approaches to 0. So as x approaches to negative infinity, y approaches to 0. So therefore, the horizontal asymptote is y equals to 0. So this is everything we have learned so far. So let's move on to the exponential function. So the exponential function, I already set up the notes for you because I think it is better to write everything out first and then introduce what I wrote instead of speaking and writing at the same time. Alright, so exponential function. So we have f of x equals to b raised to the x power. So let's quickly go back to the previous page, and then in these 6 functions, do you see that the base is x? So x is the base, right? And then the exponent is a real number. So for the linear function, x exponent is 1, quadratic is 2, cubic is 3, square root is 1/2, cube root is 1/3, the reciprocal is -1. So for these 6 functions, the exponent is a real number. The power, the exponent is a real number. Second power, third power, 1/2, 1/3, -1, first, so on and so forth. But for exponential function, do you see that the base is just a real number? So the base b is just a real number, and you have to specify that b cannot be equal to 1, because when b is equals to 1, 1 raised to any power is equals to 1, then the function is not interesting at all, right? When b is equals to 1, there is nothing to analyze, and we want the base to be greater than 0, all right? We want the base to be greater than 0. So for b to the x, and then here is the graph. This is an increasing function, right? As x increases, y increases. And then there is no vertical asymptote, because x can be anything you want. You are choosing an exponent only, so you have a base. So let's say base equals to 2, equals to 5, equals to 10, equals to 1/2, equals to 1/3, anything you want, any positive number you want, you pick an exponent. So you are picking a number, multiply itself a few times. All right, so there is no restriction for x, therefore there is no vertical asymptote. And then what about horizontal asymptote? The horizontal asymptote is y equals to 0, because as x approaches to -infinity, you have a base b raised to -infinity. Then since that is a negative exponent, you bring the b and the infinity down to the exponent, so you have a 1 divided by a huge value. For example, you take 2 raised to infinity, then you get a very large value. 1 divided by such large value is very close to 0. Actually, you know what? I should change this to approximately equals to 0. So as a result, as x approaches to -infinity, so if you look all the way to the left-hand side, y approaches to 0, and therefore the horizontal asymptote is y equals to 0. So we can put it up like that, so that this is the horizontal asymptote. So we can write HA, that is y equals to 0. So for the domain, no restriction for x, then x is all real numbers from -infinity to +infinity. And then since the curve is always above the x-axis, so this y equals to 0 is a horizontal asymptote, right? So that means the curve will never touch the x-axis. So it doesn't matter what x value you choose, all right? Y will never be 0. So you take a non-zero, multiply itself a few times, you will never get a 0, right? It doesn't matter what number you pick. Think about a number in your mind, and then multiply that number by itself a few times. Are you going to get a 0? No, right? So that's why for the range, y is always greater than 0. So that means the curve, so this curve is always above the x-axis. And then let's dive into the graph. So for the graph of exponential function, I decide to use table value. So every time you want to find out the graph of a function and you don't know any graphing techniques, use table value. Table value means you pick a few numbers for x. So for every number you pick for x, plug it in, you get a y. So every time you get a y, you get an ordered pair, right? So plot the points and then line up the points, so you will get the basic shape of the function. All right, so we are trying to do y f of x equals to 2 raised to the x power, and then what about x greater than or equal to 0? Let's look at the table value. So I pick a 0, 1, 2, 3, 4, 5, and then you plug it into the exponential function. So 2 raised to the 0 power is 1. That is not 0, right? So 2 raised to the 0 power is 1. 2 to the first power, 2 to the second power, third power, fourth power, fifth power. And then as you can see, if you keep multiplying 2 by itself many times, the y value is getting bigger and bigger and bigger, right? So as x goes up, y goes up. So you have 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. So when x is 0 or above, you can see that y is getting bigger and bigger, right? Look at the graph on the right. And then look at the piece where x is positive. That means look at the piece that is on the right-hand side of the y-axis. So as x goes up, y goes up. Another way to say this is as x increases, y increases exponentially. We use this word as x increases, y increases exponentially. It's no longer linear. So the rate it goes up is no longer constant, right? As x goes up, y goes up exponentially. Another way to think about this is y goes up really, really fast. It's not linear anymore. Linear is constant, right? The slope is always 2. The slope is always 1/2. That is for the linear function. But for exponential, well, y goes up exponentially. That means pretty fast. Okay. What about x less than 0? So here, let me correct a little mistake that I wrote. So this should be just a less than, because we already did an equal, right? So when x is less than 0, we pick -1, -2, -3. I pick -1 to -5. So here is one thing that you have to know. So we have what? We have f of x equals to 2 to the x power, right? So when x is equals to -3, then you have 2 raised to the -3. So that brings the 2 and the 3 down to an exponent. So when you have that, this is a pretty small value. Do you see that? As if you change the -3 to a -10, so if you change the -3 to a -10, do we agree that we have 1 divided by 2 to the 10? So if you compare this is bigger, and then 2 divided by 1 divided by 2 to the 10 is much smaller. So that means as x approaches to -infinity, do you see this? From -1 all the way to -5. So if you keep moving to -6, -10, -20, the y value is getting so small, because take a look at the y value. You have 1 divided by a very large denominator. Okay, you have 1 divided by a very large denominator as x approaches to -infinity. So therefore, the corresponding y value is getting very small. Take a look at the decimals. From -1 to -5, it just got so much smaller, right? From -1 to -5. So as x goes to -infinity, the denominator is getting so big. So therefore, y is getting closer and closer to 0. All right. So if you pick a -infinity, right, 2 raised to the -infinity, you toss the whole thing down to the denominator. So and then you have 1 divided by this large quantity, then you will get something very close to 0. And therefore, y equals to 0 is a horizontal asymptote. And then take a look at this piece. As x approaches to -infinity, the curve is getting closer and closer and closer and closer to the x-axis. One more time. As x approaches to -infinity, y is getting closer, 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 and closer to the x-axis. But the curve will never touch the x-axis, because the x-axis, which is y equals to 0, is a horizontal asymptote. It's getting closer, but will never touch, cross, or intersect the x-axis. All right, so that is the graph of 2 raised to the x power. All right, okay, we have more, right? So this one, I pick x equals to -100, right? So 2 raised to a negative exponent, that is 1 divided by this large quantity, then you get something very close to 0. So therefore, in conclusion, for this exponential function, it is an increasing function. We have a horizontal asymptote at y equals to 0, no vertical asymptote. X, you can be anything you want. The range is y greater than 0, so that means the curve is above the x-axis, the domain, so x can be anything you want. So what happened if you change the x to a negative x? So for negative exponent, so we still follow the same rule for the base. Base cannot be equals to 1 and base must be greater than 0. And then here is the graph if you change the x to negative. All right, so to analyze this, we will be using a function y equals to 2 raised to negative x. So looking at this graph, this is a decreasing function. We have one y-intercept, no vertical asymptote. X can be anything you want. And then domain is all real numbers. And then the range, y is greater than 0 because the curve is above the x-axis. All right, so let's take a look at this function, 2 to the negative x. All right, so this time I put a negative in front of the x, so using negative exponent that bring the 2 to the x down to the denominator. Let's test x equals to 0 or bigger. So I test x equals to 1 to 4 here. X equals to 1 to 4. So what happened when x goes up? So as x goes up, you have, so as x goes up, so let's say x equals to 5, then you have 1 divided by 2 to the 5. So that means you have 1 divided by a very big denominator. Then you will get a very small y value, right? So take a look. So as x goes up, do you see this? So here, this line. Do you see that y is getting smaller and smaller? Because all the works are being done in the denominator. You are making the denominator bigger, and then you take a 1 divided by a big denominator. Of course, you will get a very small decimal. So for this plug-in, this table value, one conclusion that we made is as x goes to positive infinity, we have a very large denominator. 1 divided by such a large denominator is something close to 0. And then therefore, we have a horizontal asymptote at y equals to 0. And then take a look at this piece right here. Okay. So let me erase the line for you, this piece right over here. So as x approaches to positive infinity, the curve is getting so close to the x-axis, but the curve will never touch the x-axis. So therefore, y equals to 0 is a horizontal asymptote. So let's take a look at the negative side. So when x is negative, so let's say x equals to -1, then we have two negatives, right? So we have 2 to the negative x. When x is equals to -1, we have 2 negative -1. Then that is 2 square, which is equals to 4. So since the two negatives becomes a positive, so when you raise the x value from -1 to -4, then you are making the y bigger and bigger, because the two negatives, they just get rid of each other, right? Minus negative 2. So that becomes a positive 2. Negative -1. That becomes here. I was writing too fast. Negative -1, right? So this is a 1, then you have a 2, right? So the two negatives get rid of each other. So therefore, you only have a base raised to a very large exponent, so therefore y is getting bigger and bigger. So you have -1 2, -2 4, -2 8, this is supposed to be -3, right? So this is supposed to be -3 8, and then -4 -16. So as x approaches to negative infinity, you have 2 raised to a large power, then you get an infinity. So that's why I have this piece. All right, so overall, this is a decreasing function, right? And then what else do we say? The domain is all real numbers, right? No horizontal asymptote. And then the horizontal asymptote is y equals to 0. And then there is no vertical asymptote. And then the domain, the range, is y greater than 0. All right? So if you put both functions on the same window, so one for positive exponent, one for negative exponent, here is the comparison. So this is an increasing function, this is a decreasing function, right? The negative exponent. And then the positive exponent is an increasing function. And then for both functions, the domain, all real numbers, they are both, for both functions, y is greater than 0. And for both functions, horizontal asymptote is y equals to 0. And for both functions, there is no vertical asymptote. So that is the introduction to exponential function. All right, so that is the end of this video. If you think my instruction is straightforward, very clear, very helpful, give me a like. Feel free to share this video on any social media, especially Facebook for me. If you are new to the channel, please take 2 seconds to click the subscribe button down below. I truly appreciate your help. I will see you all in the next video. Signing out.